go ahead and go over that too, just so we know about how many class periods we have left. So we'll pull up the calendar. So we're here at the 20th of April. And so next week we've got the 25th on Tuesday, the 27th. Then after that, we've got what's called our dead week. So we'll still be meeting on the 2nd of May and the 4th of May. And then again, our final will be on Thursday, May 11th. So next week will probably be our last time when we actually have homework due. I'll give you a practice final things next week to start. And dead week down here in May, we'll just use that for going over questions on the final, the practice final, and getting ready for your final exam. So next week will be our last real lecture time. After that, that Tuesday and that Thursday, we will spend those 2 class periods getting you ready for the final. Students usually do very, very well in the final, better than any other exam because we go over it and we go over it. Okay. So let's go ahead now and look at question 6, and this is over variation. Okay, so let's see what we have here. Sorry, question 7. So question 7, this is going to be a variation question, and it says, for a fixed amount of principal, the simple interest varies jointly, and jointly just means you have multiple variables going together, with a rate and a time. If the simple interest is $1,050 when the rate is 3% and the time is 7 years, find the simple interest when the rate is 5% and the time is 10 years. Okay, so what we're going to have to do is we're going to have to set up this formula. Right, so we set it up, we find our K, then we plug in the new values and calculate a new answer. So let's think about what we need. This is a joint variation question. It doesn't say anything about inverse, so that means these are going to multiply together. So let's see what we've got. Simple interest varies jointly with the rate and the time. So let's come up with our formula. Okay. For a fixed amount of principal, the simple interest rate varies jointly with the rate and the time. So the interest is going to equal K times the rate times the time. Now, what we have to be careful of is when we use the interest rate, that interest rate has to be as a decimal. So the interest rate will be as decimal. So it says if the simple interest is $10.50, so that goes here. K is unknown. We have a 3% rate, so 3%. Just so we remember, 3% is 0.03. And we're going to use this for 7 years. So we can now calculate out our K. We always have to find K. K is the unknown. In this case, K would be the principal, the starting amount. So we'll go ahead and multiply. So 7 times 0.03. That comes out to be 0.21 K. And then we've got 1050 over here. Then we'll divide by 0.21. And that is now going to leave us with our value of K. So 1050, divide that by 0.21. And that comes out to give you a K value of $5,000. In this case, K would be the principal, how much money you started with. Now we can rewrite our equation. So the interest is going to equal our 5,000 times the rate times the time. Right? So there's our new formula. So all of these are the same. We build our formula. We find that value of k. Once we have the value of k, we can then rebuild our formula and use the new components to find, in this case, our new interest. So now, what do? We want to find the simple interest now when we've changed the rate to 5% and the time is 10 years. So now this is the new part here. And the new rate is going to be 5%, so that's 0.05. The new time is going to be a little bit longer. It's going to be 10 years there. Plug our values in. So the interest is then going to be our 5,000 times 0.05 times the 10 years. Multiply all those together. So we have our 5,000. We'll multiply that by 0.05 and multiply that by 10. And that comes out to now be $2,500. And if we did it correctly, that should be one of the answers, and that looks like answer B, doesn't it? Is everyone okay with how I set that up? Joint just means we have multiple variables. So they're always going to be multiplied unless it uses the word inverse, right? If it says inverse, that means we divide. Otherwise, we multiply. Plug in the values that we were given, find our k, rewrite our formula, plug in the new values, recalculate, in this case, the interest. Do we need to look at any others? Are there any others that you would like for me to work through? Anybody have any others? Okay, well, if not, then we will move on, and we will start now 7.3. And 7.3 is radicals. There are some sections that we don't really cover because they're not really used in college algebra. We don't look at a lot of different roots. We look at only primarily at the square root. So 7.3, we're going to be talking about roots, square roots specifically, and we're also going to be talking about the distance formula and circles. So those are the three topics that we're going to be covering. So what we need to first learn how to do is we need to learn how to break up square roots. We're not going to look at cube roots or fourth roots or any other root. We're going to focus only on square roots. Now some of these we are already familiar with. And some of these we can use our calculator on. So we know, for example, that the square root of 4 is simply what? Simply 2. And we know the square root of 25, well, the square root of 25 is simply 5. What happens if it doesn't break up nicely? So let's look at this one. Let's look at the square root of 44. Now, how is that different? Well, if I try to use my calculator here, which you always start using your calculator, and depending upon what type of calculator you have, you'll have a square root key somewhere. Mine happens to be in blue, so you'll type the second square root, wrong key there, second, a square root, and then let's say 44. Now, that comes out to be a decimal. All right? And we don't want decimals. What we need to do is break down that square root if possible. So we don't use decimals at all. We always want the exact root. Now, when we think about square roots and we break them down, they're going to be pairs. So we're going to take this 44 and we're going to break it down. We're going to break that 44 down into, well, when I look at this, we've got 44. Those are the same. So we can break this down into 4 and 11, right? Because 4 times 11 is 44. Now, we need to break these down further if we can. 11 will not break down, but we know that 4 breaks down into 2 and 2. Now, how do we work with these roots? Well, we work with these roots by looking at pairs. And these pairs come out as 1. So this pair of 2's right here, the pair of 2's, well, they come out as 1, 2. And we're going to do a lot of these. What's left over that doesn't have a pair? The 11. So the square root of 44 would break down into 2 square root of 11. So we just factor them down. Let's try another one. How about the square root of 54? Let's see how we can break down 54. Well, 54, what I usually do is I look at it based upon the end number. And the end number in this case is a 4. That's an even number. So it's going to have a 2 in there. So let's start by dividing it by 2. And 54 divided by 2 is going to be 27, right? Okay, so 2 times 27 gives you that 54. Now we can break down that 27 a little bit further, because we can break down that 27 into 3 and 9, and 9 is a perfect square of 3 and 3. Now, what we want, and this is important for college algebra, because we break down a lot of roots in college algebra, is we want pairs. So this pair of 3's right here, okay, they're linked together, and that pair of 3's, well, that comes out as a single 3. So that's gone. Now, what's left over that doesn't have a pair with it? A 2 and a 3. So that would just be that we multiply them together. Underneath that root, 2 times 3, which then that comes out to be a 3 in front. And 2 times 3, that makes it a 6. So that would break down, square root of 54, would break down into 3 square root of 6. Let's try another one. How about the square root of 405? They're all going to be done in a similar way. When we look at 405, well, again, we look at what it ends in. 405 ends in a 5. So I'm going to divide this first by 5. So 405, we're going to divide that by 5. And that's 81. Now, we want perfect squares. And 81 happens to be a perfect square of 9. So we can break this down into 9 and 9. Now, we do not need to break this down any further because we want pairs. And these 9's, they could go further, but they're already paired together. So those 2 9's are going to be paired together. And that's going to come out to be 9. That's out in front. And what's left over? Square root of 5. Let's try another number. A couple more of these. This is a skill that you need to make sure you can do for college algebra. Is break these roots down. Very important. That's what we do in this course, is we get you ready for college algebra. So I always try to focus primarily on the topics that I know you're going to need. You need to know how to break down these square roots. So let's try 288. And it ends in an 8. 8's an even number, so we can start with a 2. 2 and 144. Well, we're in luck because 144 is a perfect square of 12, right? So we can break this 144 down into 12 and 12. What can we now do? Well, the 12's are here. They are paired up together. So 12 comes out, gone. And what doesn't have a pair? A 2. All right, let's do one more, and then we'll talk about imaginary numbers, and then we'll look at variables. So let's try another one, just one more of these. How about the square root of 1215? So let's try to break down the square root of 1215. Now, 1215 ends in a 5. So I know a 5 needs to go in here. So we'll start with that. 5. And then 243. Now you always check to make sure that that's not a square. Because if it's a square, you're done. I don't think 243 is, but let's check. Okay, the square root of 243 is not a perfect square. But I can break it down. It ends in a 3, so we're going to try a 3. Well, that's 3 and 81, right? And 81, we're in luck, because 81 is a perfect square of a 9. So that means the 9's come out, and they're gone. Now, what's left over that doesn't have a pair? 5 and the 3, so those get multiplied together. So that gives you for your final answer 9 square root now of 15. Now let's talk a little bit about negatives and how they work. You cannot take the square root of a negative number. In your previous courses, if you try to do that, that would come out as an I. Or it's not an I, but that would come out as not a real number. And if it's not a real number, well, what is it? Well, it's called imaginary. So here's our definition. I equals the square root of negative 1. So that's something that we have to remember. And you'll see this more in college algebra. So how would I evaluate this one down? How about the square root of minus 25? The minus is inside. Very important to notice that the minus is inside. Well, what do we know about 25? 25 is a perfect square of 5. Now, because this negative here, that's going to come out as an I. So the square root of a negative 25 would come out as 5i. Same thing with the square root of, let's say, a negative 36. Square root of 36 is 6. The negative here brings out an I. They also may need to be broken down. So let's look at one where we have to break it down. How about the square root of 180? And let's make it negative inside. Well, how do we break down 180? It ends in a 0, so we're going to use a 10. 10 and 18. 18 breaks down into 2, right? And 9. And we're in luck because 9 is a perfect square of 3 and 3. How can 10 break down? Well, 10 can break down into 2 and what? 2 and 5, right? So we need to break everything down and get as many pairs as we possibly can. Remember, the pairs come out in front. So we have a pair of 2s, and we also have a pair of 3s. Let's write out what we've got. We've got a pair of 2s. So when they're paired up like that, they come out as 1. So those are gone. We have a pair of 3s. So that comes out as a single 3. The negative here brings an I out in front. And what's left over that doesn't have a pair? 5. So it's left underneath the square root. Now, how do we condense this down? We multiply in front. So 2 times 3 is a 6i. And what's left over? Square root of 5. And there's your answer right there. We broke it down. And multiply what's left by what's left over. If the negative's out in front, it stays out in front. So you've got to make sure you know where the negative is at. So let's look at this one. Let's look at the negative out in front of the square root of 125. Now notice the negative is in front, so it's just going to come out in front. Right? So it's not underneath. Underneath comes out as an I. In front, it just comes along. Now what about 125? Well, 125 ends in a 5 again. So we can use 5 and 25. 5 and 5. Now we want pairs. So this is a pair of 5s. They're linked together. So that comes out as a 5. There is no I because it's positive underneath the root. And what's left over that doesn't have a pair with it? 5. So that would come out as 5 square root of 5, right? And it'll be negative out in front because that comes along with it. One of the most commonly made mistakes that I see in college algebra is this. So let's look at this one. We'll do a real easy one here. What happens is students look at this and they say, well, there's a negative and a negative, and I can make that positive. That doesn't work in this case. They are separate because that radical separates them out. So you do what's underneath the radical first. What's the square root of 36? That's easy. That's a 6. Okay. This negative here, all right, is going to bring an I out there with it. And what about the negative in front? The negative in front just comes down. So that would come out to be a negative 6I. You cannot just simply cross them out and say negative and negative makes it positive. It doesn't work like that. In order of operations, we have to do our root first, and then if there's a negative in front, it just gets drug along. Now, we talked about numbers quite a bit. Now we're going to talk about variables. And when we talk about variables in the square roots, we're going to half them. So again, we're looking for pairs. So for variables, under the root, you half the power. Okay, so for variables underneath that root, we half that power. So let's start off with numbers and variables put together. Let's try to break down the square root of, let's see, the square root of 147, p to the 5th, q to the 4th, z to the 10th power. So we're going to try to half these powers. And first thing we're going to work with is the number. So let's do that first. 147. Well, 147 ends in a 7, and 7's an odd number. So if it's an odd number, then we'll start with things like 3, maybe 7, maybe something like 11, maybe if they're duplicated values. But let's start with 3. 3 is a small odd number, and let's see if this is divisible by 3. And it is, right? So it is divisible by 3. And then once you divide that by 3, well, we've got a 49. What do we know about 49? Again, if you remember your squares, 49 is a perfect square of 7. So now, the 7s can come out. And that's gone. And what's left over? Well, what's left over is a 3. Now let's look at our powers. We're going to look at the p here. Well, does 5 evenly divide by 2? Let's try it. 5 divided by 2. 5 divided by 2 does not divide out evenly, right, because we have to divide it by 2. We get 2.5. So what are we going to do? Well, that 2, the whole number out in front, that tells you how many come out, and we have a remainder. So when we look at that p to the 5th, we can look at it either by circling it, writing it out, or by just dividing by 2. So if we divide by 2, that gives us our 2.5. So that means we have a p squared comes out, and a p is left over. Another way to look at that is you have 5 of these p's stacked together, and we want groups of 2. So this is a group, and this is another group. That p is the leftover part. So that's why it comes out as a p squared, and a p is left over. Or you can just divide it by 2, and if you have a 0.5, that means you have a remainder. What about q to the 4th power? Well, 4 divided by 2, that's nice and even, comes out to be 2. So what's going to come out with that one? Q squared. What about z? Z to the 10th. Well, 10 divided by 2 is a 5. That's it. That's going to be your final answer there. 7 p squared q squared z to the 5th square root of p. Let's do probably 2 more of these. You'll see these a lot in college algebra. Again, I'm picking topics and going really far into detail of topics that you need for college algebra. So there's some parts of chapter 7 that aren't nearly as important as breaking down these square roots. So let's do another one. Let's put a minus in front. Let's look at the square root of 81, x to the 12th power, z to the 9th power, p to the 7th power. The first thing I would look at is 81. Well, that's nice because 81, perfect square of 9. So that comes out. And now let's look at the x's. Okay, x's to the 12th power. Okay, 12 divided by 2 is a 6, so that comes out as a 6 there. What about 9? Let's look at 9. 9 divided by 2, that's 4.5. So that means 4 of them come out, so that's z to the 4th. And we have a 0.5, so there's a z left over. If there's a 0.5 when you do this, you just leave it in there. Leave one of them in. What about p to the 7th? Well, 7 divided by 2, that's a 3.5. So that means we have p to the 3rd, because we need 3 of those. We have a 0.5 for the remainder, so p comes out and stays there. So it stays inside. So that would be our final finished answer there. Okay. Hopefully these are kind of making sense, right? So we just break up our roots and go from there. Now that we've talked about roots, we've talked about how to break them down, we've talked about imaginary numbers with the I, we're now going to discuss the distance formula. And you'll use this again in college algebra. In Chapter 2 of college algebra, when we look at lines and points, we talk about the distance formula. Here's our distance formula. The distance formula is d equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So there's our formula. Now we set it up the same way that we use the slope formula. So we've got 2 ordered pairs, x1, y1, x2, y2. And we're going to plug them in, and then we're going to have to work with our formula. So we're going to do a couple of these. And then we'll look at circles. So let's Let's do 2, maybe 3 of these if we need to, and we're going to find the distance. And I'm going to give you 2 points. How about -5, 4, 7, +2? So the first thing we're going to do is we're going to take our ordered pairs and we're going to label them. So this is x1, y1, x2, and y2. So these are our formulas, our pieces labeled into our formula. Now look at our formula. Here's our formula. What are we going to have to do? We take the x's and we subtract them. We take the y's and we subtract them. We square and we put it all back together. Now we do have to be careful if we have any double negatives. So let's look at our formula here. We're going to plug in our values. So d equals the square root of x1 minus x2. So that's a -5 minus 7. And then we use parentheses. We have to square that. And then we've got a plus. Okay, then we have the y's and we subtract them. So we have 4 minus 2. Quantity squared. Well, watch your signs here. -5 minus 7. That makes it a -12. And we'll square that in a moment. 4 minus 2. Well, that's a 2 squared. Breaking this down, what do we know about -12 squared? Well, when we square a negative, it becomes positive, doesn't it? These should always be positive at the end. So -12 squared becomes a positive 144. And 2 squared is a 4. We're going to add those together, and now we're going to get the square root of 148. Sometimes it will break down. Sometimes it won't. What's underneath that square root? So always, always check. We'll see if this will break down. We've got a 148. And it ends in an even number, so we're going to divide by 2. Right, so we'll divide that by 2. So that's 2 and 74. Another even, so we'll divide that by 2 again. 2 and 37. 37 is not going to break down any further. We do have some pairs. So we have a pair of 2's. These go together. So that is then going to come out as a 2. They're gone. What's left over? Square root of 37. Do not give me the decimal equivalent. I want the radicals. So make sure that your answer looks like this. Not the decimal. I want the radical. Let's do another one. So let's find the distance. How about 4, -3, and -7, -12? So we're going to be trying to find our distance here. What do we first do? We label our points. So x1, y1, x2, and y2. Just like they were going into the slope formula. Right? Just that we have to subtract them instead of adding, and we have to square instead of divide them out. So let's write up our formula. D equals the square root x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. And we'll fill in our pieces here. So that is going to be the square root of 4. Now watch for double negatives. We have a negative here, so that's going to be a minus. We have a double negative, -7. That's the most commonly made mistake, is the double negative. Okay, so be very careful with that. And then we've got a plus. we have a minus 3 minus a minus 12. And we know that double negative makes it positive, and so does this one. So let's see what we've got. Well, that's a positive 4 plus 7. That gives you an 11. So we've got an 11 squared. And then we've got a minus 3. Minus 3 plus 12 makes it a 9 squared. 11 squared is 121, I believe. So 11 squared is that 121. 9 squared is 81. We're going to add these together, and that gives you the square root of 202. Sometimes the roots break down. Sometimes they may not. What we want is pairs. So we start with our 202. It's an even number, so let's divide that by 2. We get 2 and 101. However, 101 is what's called a prime number because nothing goes into 101. So it can't go down any further. 2 has nothing to link with it because 101 won't divide by 3. It won't divide by 7. It won't divide by 9. None of that. So it will not break down. This 2 has nothing to link with it, so we cannot break it down. So your answer would then just simply be square root of 202. This 202 will not break down. Now you can also have square roots in these. So let's again find the distance. About 4 square root of 11, comma, 5 square root of 2. And about 3 square root of 11, comma, minus 4 square root of 2. Now, don't overcomplicate it because of the roots. Okay, that's okay. Roots will just go together. So these have to be the same, which they are, and they're just going to go together. We've wrote up our formula enough now. I think we can just plug our values in. And there's one of these in your homework. So D equals now the square root of 4 square root of 11 minus 3 square root of 11. And we have to square it. We have a plus 5 square root of 2 minus a minus 4 square root of 2. So there's our formula. Now these roots can go together because these roots are the same, so think of it like an x. If I had 4x minus 3x, well, that would give you a single x, right? Okay, so let's go ahead and put these together. 4 minus 3, that leaves you with just a single square root of 11. And we're still going to have to square that. What about over here? Over here we have a double negative. Double negative makes that positive. And 5 and 4 makes it 9. We still have the square root of 2. Okay. Did you find your homework, Chase? Okay. So now, how do we handle this? Well, what happens when we square a square root? We think of opposites in math. So the opposite of addition is subtraction, right? Opposite of multiplication is division. What's the opposite of a square? Well, the opposite of a square is a square root, or vice versa. So a square can cancel out a square root. So this square can cancel out the square root here, and that's going to leave you with the square root of 11. What about the next one? Well, for the next piece, this 2 has to be distributed through. So we need the square to go through. So 9 squared. It's not 9 times 2. It's 9 squared. 9 squared is 81. The square here and the square root cancel out, and that leaves you with a 2. Now we can put these together, and that's going to be the square root of 11 plus, we've got 81 times 2. That's 162. And we'll go ahead and add those together. And that gives you now the square root of 173. May or may not break down. You always check. It ends in a 3, so we're going to try a 3. 3 will not go in there. We might try, let's say, 11. 11 doesn't go in there. We might try a 7. You just try numbers until you're confident it won't break down. 7 does not go in there. We might even try, let's say, a 17. Won't go in there. 19 won't go in there either. Nothing goes in there, right? It's not going to break down at all. It doesn't break down at all. You always have to check, though, so it doesn't break down. So your final answer then would just simply be the square root of 173. Sometimes they'll break down, especially on these, they usually won't. But sometimes they will. Most of the time when it has the square roots underneath here, they're not going to break down. And the last part of this section is something that you're going to cover in greater detail in college algebra. And that's circles. We're barely going to touch on the basics of circles today. In college algebra, though, you're going to go into a lot of detail about circles. We're just introducing the basic concepts. Again, in college algebra, you'll see this in chapter 2. It's actually 2.2, where we talk about circles. It's an entire chapter. Intermediate, though, we're just introducing concepts. Now, when we talk about a circle, what does a circle need? Well, a circle needs a center and a radius. So a circle is going to need a center and a radius. How do we graph a circle? Well, what we do is we plot the center and then we move around it with the radius. So let's just begin by graphing a couple of circles. So we're going to graph the circle. With a center at 9, -1, and a radius of 3. So we're going to try and graph a circle, and this is very easy to do. We're going to try to graph a circle when we have a center and a radius. How would I do that? Well, first thing I do is I have a center and I plot that point. Careful with the x and the y. Remember, this goes x and y. So 9, -1 would be over 9 units. 6, 7, 8, 9, and down 1. So right there is my center at 9, -1. And then what do? We go 3 units in each direction. Up, down, left and right, curve them together when we're done. And that's it. So here's our center. We're going to go up 3. So 1, 2, 3 units up. We're going to go 3 units down. So 1, 2, 3 units down. We go 3 units to the left. So 1, 2, 3. And we go 3 units to the right. 1, 2, 3 units to the right. And then we've got these dots, and we're going to connect them together. And we're going to make our circle. That's it. So all you need for a circle is you need a center and you need a radius. We'll do another one of these here in a moment, but let's first talk about how the center radius or standard form of a circle works. Some textbooks use standard form when they talk about circles. Ours uses the center radius form. And that's what we're going to be calling it. So I don't call it the standard form. I call it the center radius form, just like our textbook does. So we're going to look now at the center radius form of a circle, and that's x plus h, quantity squared, y plus k, quantity squared, equals r squared, and the center is negative h, negative k, and the radius is simply r. So that's going to be our radius. Now we're going to do several of these where we find the center and find the radius. Then we'll graph a couple of them. Then we'll do the opposite. Then I will give you the formula, and you'll find the center and the radius. So we'll do both. So let's go ahead and write this in center radius form. We'll do this one first. We're going to write this in center radius form. And let's say we have a center of 5, negative 2, and a radius of 4. Now, when we go from the center and the radius to the center radius form, the first thing we need to remember is the center. Look at the center. Minus, positive. Minus k, plus k. So whenever you go from the center radius form to the center of a circle, either way that you go, you always switch the signs. So when we switch our signs, we've got an x, and this was originally a 5, so we make it a minus 5. Switch your signs, and this was a minus 2, so that becomes y plus 2. And over here, this is our r. We want r squared. So we take it and we square it. And 4 squared is 16. So in center radius form, this would be x minus 5, quantity squared, y plus 2, quantity squared, and it doesn't equal 4. Very important you see it equals 16. So we have to square it. Let's do another one. Then we'll do the opposite and we'll graph a few of them. So again, we're going to write in center radius form. And let's say we have a center that's at 8, 3, and a radius, let's say the square root of 13. So Not much to do with these, but you will see them in college algebra quite a bit. The important thing to remember is we switch our signs. So we do x first and y. So that's going to be an 8. We switch it. So that's going to be x minus 8. The 3, we switch it. It's a positive 3. So it comes down as a negative 3. Now, what about the square root of 13? Well, the square root of 13, we still have to square it. And we've talked about this numerous times. What happens when I square a square root? They are opposite. They cancel out. So that is then 13 on the right-hand side. And we've got x minus 8, quantity squared, y minus 3, quantity squared. That now equals your 13. Very important, though. What did I do? Switched my signs. Now we're going to go the opposite. I'm going to give you an equation, and we're going to graph this circle. So we're going to find the center. Radius, and we'll graph the circle. So find the center, the radius, and graph. X plus 1, quantity squared, y minus 3, quantity squared, equals 25. Okay, so we're going to do exactly what we did a moment ago. When we go from the center radius form to the center of a circle, or vice versa, we always have to switch our signs. So right now it's 1 and negative 3. We're going to have to switch them. So when I switch them, it becomes minus 1 and positive 3. So that is my center. Now, this is r squared. Well, we don't want r squared. We want r. So r squared equals 25. We've talked about this before. How do we get rid of a square? Opposite of a square is a square root. So we take the square root of both sides. In college algebra, depending upon the situation, you might have a plus or minus. But that's for college algebra. In this case, we can't have a negative radius, so we don't have to worry about the minus case. So we take our square root, and what's the square root of 25? Well, the square root of 25 is a 5. How do we graph this now? Well, we graphed a few of these earlier. Well, actually, we just graphed one, but we're going to graph a few more. And what did we do? Well, we had to have our center. So the first thing that we do is we find our center. So where's our center? Our center is at negative 1, so that's back 1 and up 3. So minus 1, positive 3 is here. And what do? 5 units in each direction. So we go down 5, up 5, 1, 2, 3, 4, 5. And we're going 5 in each direction. We go forward 5 units, so 1, 2, 3, 4, 5. And we go back 5. 1, 2, 3, 4, 5. Okay, so there's 5 units in each direction. And now we simply connect them together the best that we can. And there's our circle. So simple enough. But I did really want to introduce circles. That way you've at least seen them when you see them again in college algebra and you do a lot more with them. What happens if we're missing parts? Let's say if we're missing one of the numbers. We're going to, again, try to find the center, radius, and graph. So we're going to try to find the center, the radius, and we're going to graph it. Now this one's missing the x part. So let's say we have an x squared plus y minus 2 quantity squared equals, how about we use a 36. Okay, so very easy. I don't want you to miss these. These are good questions to put on a final exam because they're easy. So you'll probably see something like this on your final. We want to find the center, radius, and graph. Okay, now what about the x part? We don't have any number with the x, do we? So we're going to use a 0. So the center then would be 0 for the x because there's no x component. It's not negative 2, it is a positive 2. And our radius is not 36, it's the square root of 36, which is then a what? Positive 6, right? What does this look like if we go to graph it? Well, when we go to graph it, we're going to be at 0, 2, so that's right here. And then what are we going to do? We're going to go 6 units in each direction. So starting from the center, we go up 6. So 1, 2, 3, 4, 5, 6. So 6 units up, 6 units down. 3, 4, 5, 6. Okay, 6 units down, 6 units over. 1, 2, 3, 4, 5, 6. So roughly 6 units here, and 6 units forward. 1, 2, 3, 4, 5, 6. Over, and then we can just simply connect these together and come up with our circle. So easy enough here. And there it is. Okay, there's your circle. We graphed it, and there is your center and your radius. We do have a little bit of time left, so I am going to go back and do maybe 1 or 2 of your homework questions from 6.5 and 6.6, because I know that sometimes students struggle with these. We've got a few minutes, so I'll probably work out 2 of these for you. We'll do a work question, and we'll do an inverse variation, just to make sure we get the correct answers for these. So let's do a work one, and let's work question 3. And this is from your homework. So there's several of these. They're all pretty much the same. 1 through 4 are exactly the same. It's just different numbers is all. And slightly different scenarios. So this is a work question. And for these work questions, what we need to make sure is we write them as a fraction. How much work is done per hour. So Frank can type a report in 2 hours. James takes 5 hours. How long will it take the 2 of them typing together? So when they work together, well, that's addition. So let's see what we have here. We have Frank, and we have James. Now, what about Frank? Okay, Frank takes him 2 hours. So how much is done in 1 hour? Well, If it takes him 2 hours to type this report, half the report's typed, right? Flip it over. 2 hours to do it. In 1 hour, he's done half of it. What about James? Well, James takes 5 hours. So in 1 hour, how much has he done? 1/5. We put them together, and that is then 1/2 x plus 1/5 x, because x represents the time. And always, always on these work questions, it equals 1. Make sure it equals 1. Every time when it's a work question, it must equal 1. Clear out our fractions quickly. The hard part is done. Multiply it all by 10. So 10 over 2, that's a 5x. 10 over 5, that's a 2x. 10 times 1 is a 10. So that's 7x equals 10. We'll divide by our 7. So x now equals 10 over 7 hours. And that should match up to one of the answers, and it does. It looks like it's going to be answer C, isn't it? This will be our last question, so I'll go ahead and pass out the sign-in sheet. We'll do one more of these from our homework. So let's do one more. Let's do an inverse variation. Let's look at question 9 now. So, resistance of a wire. It says the resistance of a wire varies directly as the length of the wire and inversely as the square of the diameter. So, what do we need to do? Write up our formula. Again, this is variation. Now, inverse means divide. Directly means we multiply. So let's see what we've got here. Resistance of the wire, so that's what we're going to start with. And we've got our K. We always have a K. Directly as the length, so that means we multiply. Inversely as the square of the diameter, so that's our diameter down below. And we're going to square it. So there's our formula. Resistance equals K, which is the unknown, times the length divided by the diameter squared. Fill in our components, our pieces here. 20-foot length of wire, diameter of 0.1, resistance of 3. So let's fill in our parts. Resistance is of 3. K is the unknown. Length is 20 feet. Diameter is 0.1, and we have to square it. Sorry, 0.1. Make sure I don't make a mistake with the decimals. It's 0.1. And we have to square it. So let's go ahead and work that out and see what we get. Down below, we'll square that first. So 0.1 squared. That gives you now 20K over, squaring that, 0.01. That equals you 3. And we can just divide. 20 divided by that 0.01. That comes out to be 2,000. So 3 equals 2,000 K. Divide by our 2,000. And that gives me K equaling now. I don't think it'll reduce down any. Nope, it won't. So that's going to give you K equaling now 3 over that 2,000. And if we wanted to, we could use a decimal just to make it a little bit easier. And as a decimal, that's 0.015. Sorry, too many zeros, or not enough. So 0.0015. Divided them, that's what we got. Okay, now we put it together, and we're almost finished. So then our resistance equals 0.0015 times the length over the diameter squared, and we're going to plug in our new values. So let's plug in our new values and find our new resistance. What would the resistance value be for 33 feet of wire? So new values we're going to be using. We've got a new length. We increased it to 33. Longer the wire, more resistance. That makes sense. And the diameter has been changed, and the diameter is now 0.01. So, plugging our values in. So, resistance is 0.0015 times that 33 over 0.01 quantity squared. You could do it in your calculator in one step, or you can write it out. I'll probably just quickly write it out. Okay, we're almost finished here. Otherwise, I'd get up and close the door, but this will be our last question. So that's 0.01. We've got to square it. And we have 1, 2, 3 zeros. And on the top, we have a 0.0015, thank you. And we're going to multiply that by our 33. And that is 0.0495. We'll divide out by that 0.0001. And that gives us then our final answer of 495 ohms. And if we did it correctly, that should be one of the answers there. I think I may have made a mistake with the number of zeros somewhere. I think it should be answer C, though, right? Yeah. I think I got mixed up with the number of zeros. Let's try this again just to make sure. We've got 0.0015. Multiply that by 33. That is that. Divide that by new diameter of 0.01. We have to square it. And I believe it should be 4. Yeah, I made a mistake somewhere with the decimals. It should be 4.95 ohms. I think I probably lost a zero somewhere. Okay, but that should be your answer on that. Okay, so that should be answer C. And I just made a mistake somewhere with the zero. Probably didn't have enough at some point in time. Probably up here. Okay. Yeah, and I see it. I probably forgot. Yeah, I forgot to square it here. Well, I squared it, but yeah. When I worked it out, I probably made a mistake. So that's why. Yeah. But it should come out to be that 4.95 ohms. So what's our homework? Well, your homework now is going to be, again, 6, 5, and 6, 6. You can do those. And today we did 7.3. And you can do all of those. So I will see everyone then on next Tuesday.